Lecture 1 of 4. Topic 7.0 Trigonometric functions. Subtopic 7.1 Trigonometric ratios and identities. Learning outcomes. By the end of the lesson, students should be able to A. Define trigonometric ratios. B. Understand tangent theta equals sine theta over cos theta. Cos 90 degree minus theta equals sine theta. Sine 90 degree minus theta equals cos theta. Tangent 90 degrees minus theta equals cot theta. C. Use for some particular angles. D. Evaluate trigonometric functions for any angles. And E. Use the Pythagoras identities, such as sine square plus cos square equals 1, 1 plus tangent square theta equals secant square theta, and 1 plus cot square theta equals cosecant square theta. Trigonometric ratios of a right-angled triangle PQR. We have this PQR, right-angled triangle. This is the adjacent QR. PQ is opposite and PR is hypotenuse. Sine theta is opposite over hypotenuse. That is PQ over PR. For cos theta is adjacent over hypotenuse. Okay, so we have QR over PR. And tangent theta is opposite over adjacent equals PQ over QR. 7.1 Trigonometric ratios of sin theta, cos theta, tangent theta, cosec theta, secant theta, and cotangent theta. For any acute angle theta, there are 6 trigonometric ratios, each of which is defined by referring to a right-angled triangle containing theta. So this is theta, the acute angle theta, while this angle must be 90 minus theta. The opposite is y, adjacent is x, hypotenuse is z. From the diagram, you can have sin theta is y over z. Cos theta is x over z. Tangent theta is y over x. And cosecant theta is 1 over sine, so 1 over y over z is z over y. Secant theta is 1 over cos, 1 over x over z, that is z over x. And cot theta is 1 over tangent theta is 1 over y over x, so we have x over y. Example 1. If cot theta is 3 over 4 and theta is an acute angle, this is acute angle, find tangent theta, sine theta, secant theta, and cosecant theta. Solution. The given info is cot theta equals 3 over 4. Coming from here, and cot is 1 over tangent. Now we can have tangent theta as 1 over cot theta, so 4 over 3. Tangent theta, so we have 4 over 3, so we have opposite must be 4, and adjacent is 3, so the hypotenuse must be 5. Okay, from this diagram, you can list down now all the trigo function. That is sine theta equals 4 over 5, cosecant theta is 1 over sine theta, equals 5 over 4. Cosecant theta or cos theta is 3 over 5. And secant theta is 1 over cos theta equals 5 over 3. Relationship of sin theta, cos theta, and tangent theta. From the diagram, we can have now sin 90 degree minus theta is, okay, now we are referring to this angle. Angle is 90 minus theta, and this is the angle theta. Sin 90 minus theta is this angle. So we have x over z. So x over z. Cos theta, so now we go to refer to this angle. Cos theta is x over z. So what we can see here, both have the same value, x over z. So therefore, we will come out with an equation that is sin 90 minus theta is cos theta. Cos 90 minus theta is x, y over z, Sin theta is y over z. So now we can have an equation for cos 90 degree minus theta equals sin theta. C, tangent 90 minus theta equals x over y. While for the cot theta is 1 over tangent theta, 1 over y over x, which is equals x over y. So what we can observe here, we have same value as x over y. So therefore, we will come out with an equation that is tangent 90 degree minus theta is cot theta. Trigonometric ratios of particular or special angles. Equilateral triangle of sides 2 units in length. So each side should have 2 for the length, and also each angle must be 60 degree. Now we try to divide this equilateral triangle into 2 equal triangles. So therefore, we shall have 30 degree for this side, for the angle. And the opposite must be 3. From here, we can have sin 60 is 3 over 2. Cos 60 is 1 over 2. Tangent 60 is 3 over 1. Sin 30 is 1 over 2. Cos 30 is 3 over 2. And lastly, we have tangent 30 is 1 over 2. Isosceles triangle. This is what it means of isosceles triangle. We have two-sided or in the same length, and this angle must be 45, and so for this angle is 45 also, and here must be 1 and here also must be 1 because tangent 45 is 1. So this hypotenuse must be sec 1 square plus 1, it will be sec 2. From this diagram, isosceles triangle, we can have sine 45 is 1 over sec 2. Cos 45 is 1 over sec 2. And tangent 45 is 1. The values of trigonometric ratio for some particular angles are as follows. Sine 0 is 0. Cos 0 is 1. Tangent 0 is 0. Sine 30 is half. Cos 30 is sec 3 over 2. And tangent 30 is 1 over sec 3. Sine 45 is 1 over sec 2. Cos 45 is 1 over sec 2. And tangent 45 is 1. Sine 60 degree is sec 3 over 2. Cos 60 degree is half. Tangent 60 degree is sec 3 over 1. Sine 90 is 1. Cos 90 is 0. Tangent 90 degrees is infinity. Prove that cos 60 equals 1 minus tangent square 30 over 1 plus tangent square 30. We may start with the right hand side. 1 minus tangent square 30 over 1 plus tangent square 30. Tangent 30 is 1 over sec 2. So we just go to insert the value into tangent 30 on the numerator and also denominator. So we have like this. We just go to simplify. 1 minus 1 over 3 over 1 plus 1 over 3. And up there we have 3 over 2 over 3 over 4 over 3. And lastly we have half. Okay, half is cos 60. So this is equals left hand side. Trigonometric ratio for any angle. Positive angle. First quadrant. Theta is in the first quadrant. So we have sine theta, tangent theta, cos theta. If they are in the first quadrant, so it will bring positive value. Second quadrant. This theta is in the second quadrant. And this side, the acute angle, 180 minus theta. So we will have sine 180 minus theta equals sine theta. Cos 180 minus theta equals minus cos theta. Because cos in the second quadrant, it is minus. While sine just now, it is in the second quadrant, they are positive. And tangent 180 degrees minus theta, in the second quadrant, it is equal minus tangent theta. Because in the second quadrant, tangent is negative. In the third quadrant, so we have theta is in the third quadrant. And of course, this acute angle must be theta minus 180. So we have sine. Theta minus 180 degree equals minus sine theta. Tangent theta minus 180 degree is tangent theta. Cos theta minus 180 degrees equals minus cos theta. Cos theta. In the fourth quadrant we have this angle theta is in the fourth quadrant. So we should have sine 360 minus theta. This angle is equals minus sine theta. Okay, this is in the fourth quadrant. Tangent 360 degree minus theta is minus tangent theta. Cos 360 degree minus theta is cos theta. So we can summarize that all the trigonometric ratios are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant, while cosine is positive in the fourth quadrant as shown below. So we have in the first quadrant all trigo ratios positive. Second quadrant, only sine is positive. Third quadrant, only tangent is positive. And the fourth quadrant, only cos is positive, while the rest will be negative. Negative angle. The rotating arm will describe a negative angle if it rotates in a clockwise direction. To convert a negative angle to a normal basic angle, just add 360 or a multiple of 360 degree. The value of a trigonometrical ratio of any negative angle can then be found. What we have here is if it rotates in a clockwise directions. What does it mean is that it is like this. Okay, moving following clockwise direction. Example, an angle of minus 40 degree is equivalent to a basic angle of minus 40 degree plus 360 equals 320 degree. Sine minus 40 degree is sine 3 equals sine 320 degrees equals minus sine 360 degrees minus 320 degrees, and then equals minus sine 40. For cos minus 40 degrees equals cos 320 equals cos 360 minus 320 equals cos 40. Tangent minus 40 degrees equal tangent 320 degree equals minus tangent 360 degree minus 320 degree equals minus tangent 40 degree. Hence, in general, sine minus theta equals minus sine theta. Cos minus theta is cos theta, while for tangent minus theta is minus tangent theta. Because in the fourth quadrant, cos is positive, so minus cos 40 is actually cos 40 degree. Cos minus 40 degree is positive. Cos minus 40 degree. State the trigonometric ratio in acute angle. A sine 160, B cos 220, and C tangent 310 degree. The first one is sine 160 degree, so we will have here, it is equivalent to sine 180 minus 160. So sine 160 degree equals sine 20 degree. For B, cos 220. It is in the third quadrant. So we have cos 220 degree. So equals cos 220 degree minus 180 degree. So the acute angle is minus cos 40, because in the third quadrant, cos is negative. For C, we have tangent 310 degree. So we have here, 310 is in the fourth quadrant. So this is tangent. So you have tangent 310 equals tangent 360 minus 310. We have tangent 50 degree, which is negative, because in the fourth quadrant, tangent is negative. Example 2. State the trigonometric ratio in acute angle. A sine minus 25 degree, B cos minus 40 degree, and C minus 163 degree. For sine minus 25, so it might be started from here 0 until this line, minus 25, following the clockwise direction. So minus 25 degree is minus sine 25, because sine in the fourth quadrant is negative. Cos minus 40 degree. We have here cos minus 40 degree equals cos 40, because cos in the fourth quadrant is positive. Even though we have the angle is in the minus form, but then when we want to find cos minus 40, it must be cos positive 40 degree. Tangent minus 160 degree. It is in the third quadrant. So it should have tangent minus 180 minus 163, because this minus referring to the negative angle. And tangent we have here minus 17. But tangent minus 17, it is positive because tangent in the third quadrant is positive. Example 3. Find the following. A sine 120 degree, B cos 210 degree, D tangent minus 120 degree, and E is cos 630 degree. We go to the first one, sine 120 degrees. It must be in the second quadrant, 120 degree, and acute angle must be 60. Sine 180 degree minus 120, so we have sine 60. It is positive because sine is positive in the first and also in the second quadrant. The value is 3/2. B, we have cos 210. 210 is in the third quadrant. So we will have here cos 210 minus 180 degrees. We have cos 30 degrees, which is equals minus 3/2. Because it is in the third quadrant, cos is minus. Tangent 120 degrees. We will have here, it is minus. Starting from 0 here, this line, and until the line of tangent 120. This is minus, should be following the direction of clockwise, and equals tangent minus, because this is, we are referring to the negative value 180 degrees minus 120, which is tangent minus 60 degree. But then here tangent in the third quadrant it is positive, so this negative will change to positive immediately, so the value is 3. Trigonometric identities. For any position of OP, a right angle can be drawn for which we have x squared plus y squared equals OP squared equals R squared. Okay, this is the right angled triangle. The opposite is y, the adjacent is x, and the hypotenuse is r. So therefore, we will have here x squared plus y squared equals OP squared equals R squared. Dividing through x squared plus y squared equals R squared by R squared becomes x over R squared plus y over R squared equals 1. Since we have x over r is cos theta and y over r is sine theta, so therefore we will have the first identity, trigo identity, is cos square theta plus sine square theta equals 1. Divided through by x squared becomes 1 plus y over x squared equals r over x squared. So we x squared plus y squared equals r squared, we divide by x squared. So you will have 1 plus y squared over x squared, so y over x squared, r squared over x squared, r over x squared. Since we have x over y over x equals tangent theta, and r over x is secant theta, so we will have another identity, trigo identity equation. 1 plus tangent square theta equals secant square theta. Dividing through, x squared plus y squared equals r squared by y squared becomes y over x over y, square plus y square over y square, we have 1 equals r square over y square, we have r over y square. Since x over y is cot theta and r over y equals cosecant theta, so therefore we have the third identity equations. We have cot square theta plus 1 equals cosecant square theta. Example 7. Prove the identity tangent theta plus cot theta equals secant theta cosecant theta. Solution. We must start with the left-hand side, tangent theta plus cot theta. We define tangent and also cot theta, so we have sin theta over cos theta plus cos theta over sin theta for cot. Now we go to equate the denominator part. So we will have here sin square plus cos square. Okay, sin theta cos theta divided by cos. We have sin theta times sin theta is sin square. Sin theta cos theta divided by sin theta, we have cos times cos, we have cos square. Up here is the first identity. Sin square plus cos square is 1. So we have 1 over sin theta cos theta. And then you can go to split this 1 over sin theta times 1 over cos theta, which is 1 over sin is cosecant. Cosecant theta times secant theta. This is right hand side, proof. Example 8. Prove the identity 1 minus sin theta plus cos theta equal square equals 2 times 1 minus sin theta times 1 plus cos theta. We may start with the left hand side, 1 minus sin theta plus cos theta square. So we times this twice. Okay, so what we have to do, each one in the first part will be times with each one in the second part. So we have lastly, we will have 2 minus 2 sin theta plus 2 cos theta minus 2 sin theta cos theta, which is 2 can be taken outside to factorize. We have 1 minus sin theta plus cos theta minus sin theta cos theta. So what we can observe in common is cos theta and also cos theta for this part. It can be taken out to factorize. So 1 minus sin theta. So we taken out this cos theta and cos theta outside. Then we have 1 minus sin theta. And then what we have in common also after that is 1 minus sin theta here and also 1 minus tan sin theta here. It can be factorized. So we will have here 2 times 1 minus sin theta. Okay, and then this is times 1. So it's from here 1 plus here the left behind 1 is cos theta. So 1 plus cos theta, which is this is happening on the right hand side. It's proved. Example 9. Prove the identity 1 plus sine theta over 1 minus sine theta is tangent theta plus secant theta squared. We may start with the right hand side first. So we have tangent theta plus secant theta, and then square. And we go to define tangent, sine over cos, and secant 1 over cos. Square outside. This is cos theta. Okay, so cos theta is common denominator, so sine theta plus 1. So we have cos squared. What we have in the denominator is cos square is actually 1 minus sine square theta. So we go to factorize the denominator part. So we have 1 minus sine theta times 1 plus sine theta. So it can be, here it can be cancelled. The above 1, 1, and the below 1, 1 plus sine theta, and also the numerator occur twice. So we can cancel 1. So the left behind one is 1 plus sine theta over 1 minus sine theta, which is the left hand side.